Bumblebees can give traveling salesmen a run for their money by learning the quickest route between flowers. Astridi has found bees, despite their lack of maps, are able to work out the fastest and straightest path to reach nectar and pollen. While at first they fall for tempting shortcuts between food sources, they soon cut their total flight time. Scientists at Queen Mary University of London recorded the flight of bees to test out if they could solve the mathematical conundrum known as the traveling salesman problem. Professor Lars Chittka, coordinator of the study, said, "Imagine a salesman from London who needs to call at Manchester, Leeds, Glasgow, Edinburgh, and Inverness before returning home. From Manchester it is tempting to make the short trip across to Leeds, and from Glasgow it is tempting to visit Edinburgh, but a salesman who does that will soon find themselves stranded in Inverness with a very long drive home." The better solution is to travel up one side of the UK and return down the other. The result is one of the largest and most complete datasets on bee flight ever recorded, which shows bees, like salesmen, reduce their flight distance as they gain experience. Even after 50 or 60 foraging bouts, they appeared still to be finessing their route. Researchers replicated the flowers bees visit to forage using feeding stations at the Rothamsted Research Institute in Hertfordshire and tracked the insects using radar. They found the bees sped up their foraging and flew a shorter distance as time went on. This was attributed mainly to experienced bees flying straighter and exploring less, but they were also able to slightly change the order in which they visited feeders. Lead researcher Dr Joe Woodgate, from Queen Mary University of London, said, "Animals cannot inspect a map to find out where the best food sources are, or plan how to get to them. Instead, they must explore the landscape, discovering locations one by one, and then they face the challenge of integrating their spatial memories into an efficient route." The team studied 6 bumblebees making 201 flights using a special type of radar capable of identifying signature reflections from tiny transponders attached to the insects. This calculated the position of a bee every 3 seconds to an accuracy of 2 meters, 6.5 feet, for the study, published in the journal Scientific Reports. Co-author James Makinson said, "Understanding how small-brained animals like bees find efficient rules of thumb to accomplish complex and flexible behaviors has great potential to inform the development of artificial intelligence and advanced robots." It's also important to understand how bees and other pollinating insects search for food and use the landscape as crucial to managing the risks to pollinators' services posed by habitat loss and agricultural intensification. Co-author Dr Jason Lim, an electronics and radar engineer at Rothamsted Research, said, "The need to understand the movement of both migratory insect pests and pollinators is more important than ever if the current agricultural food production is going to feed a human population of 10 billion by 2050.